Hello, am I audible? Sorry for the troubles. I'll continue with the lecture now. Till now we are discussing about different types of watershed based on the size of the watershed. And we have discussed a few watersheds that we have classified based on land use. That first one is urban, second one is agricultural, third one is forest areas, and fourth one is mountainous. So now we will be talking about remaining watershed areas. That is, next one is desertile. In this case, there is, since no vegetation is there and very little rainfall, whatever rainfall that is occurring is getting absorbed by the soil. Okay. And remaining portion is evaporated. Since the nature of soil is also sandy type, stream development is minimal. Okay. Also, because of low rainfall, very little groundwater recharge occurs in this type of watershed. And the last three types of watershed are coastal watershed. So, for example, Chennai is a coastal watershed. Sorry, it has like multiple, it is a mixed type of watershed, urban plus coastal. But if you see any other coastal areas, the watershed type will be a coastal watershed, and it can be partly urban and in dynamic contact with sea. Okay. So mostly these type of watersheds are influenced by black water from wave and tidal action, and they receive high rainfall. Okay. Mostly cyclonic type, and there is no channel control inflow, which is leading to flooding in these kind of areas. So in coastal areas, the water table is also high. But the main problem they face is saltwater intrusion because the ocean water is salty. If the groundwater table, the water table is below the water table of the ocean, then what will happen is the saltwater intrusion will occur. So the groundwater will also become salty. Okay. Therefore, there won't be any fresh water available for the people that are living in the coastal areas. Saltwater intrusion is the main problem. Then last type of watershed is marsh or wetland. In this case, almost flat and it is almost flat and comprised of swamp or marshes and water courses. So they have rich wildlife and plenty of vegetation. because water is available. So since the soil is wet, evaporation is dominant, and it generally receives normally high rainfall, and infiltration is minimal. So in this case, the hydrograph peaks gradually and lasts for long time. So the peak will be occurring gradually, and then it still lasts for longer time. Okay, the peak also. And the last type of watershed is mixed watershed. So in this case, multiple land use land covers exist together. Multiple land use land cover exist together. They can be natural or man-made. Okay, so the next type of watershed is based on shape. So as we have discussed, the watershed is like this. Okay, so this length of the watershed is higher than the width. Then it is an elongated watershed. Okay, and there is a broad type of watershed where the width of the watershed is higher than the length of the watershed, and in the next type is fan shaped. So this is how fan shaped watershed looks like. Okay, and the last type of classification is based on drainage pattern. Okay, here if you see, we have different types of watershed based on the drainages. So in this case, this is a dendritic watershed. In this case, this is a parallel watershed where the drainages are parallel to each other. And in case of rectangular watershed, they are joining at right angle. So like this, we have different types of watershed based on the drainage pattern. Okay. So let's look into questions related to this topic. So based on the drainage basin is also called as option A watershed, B catchment, option C runoff area, option D streams. So we have discussed these are all the synonyms for the word drainage basin. So next question, principal factors contributing to variation in hydrological process are option A topography, option B vegetation, option C land use, option D all of the above. So if the based on the slope that is steep or mild, the hydrological processes vary based on the vegetation cover and land use. All these are the factors that contribute to variation in hydrological process. So the answer is all of the above. So the next question is dominant phase in large size watershed is overland flow, B channel phase, C both A and B, and D none. So as you remember, in case of large watershed, the channels are properly developed. So the channel phase is more dominant compared to the overland flow. In case of medium size watershed, which is the dominant phase, overland flow, channel phase, option C, A, both A and B, and option D, none of the above. Option C, both A and B, but we have learned that slightly overland flow is dominant compared to channel phase. In case of small size watershed, the overland flow is dominant. So, next question is small size watersheds are sensitive to option A high intensity short duration rainfall, option B low intensity and short duration rainfall, option C is high intensity and long duration rainfall, option D is low intensity and low duration rainfall. So we see that so the answer is option A, not C. High intensity and short duration rainfall. If there is huge amount of rainfall that is occurring in short duration, It is causing floods in small size watersheds. So the next question is the size of medium watershed is option A less than 250 kilometers square, option B 250 to 2500 kilometers square, option C greater than 2500 kilometers square, option D none. So if you remember, the size is less than 250 kilometers square. It's a small watershed. If it is greater than 2500 kilometers, it's a large watershed. So medium watershed size will vary from 250 to 2500 kilometers square. So the next question is which land use experience increase in runoff and decrease in soil erosion? Option A agriculture, option B desert, option C urban, option D mountainous. So in case of natural agriculture and the desert, there won't be any runoff much compared to, because in agricultural land the infiltration is more. In deserts we have very less rainfall, so most of it is getting infiltrated. And in case of both urban and mountainous, we know runoff will be high, but in case of mountainous, the soil erosion is also high. So the option is option C, urban, because the surface area is covered by paved material. So there will be a decrease in soil erosion. So the next question is deforestation increases annual water yield by option A less than 20%, B 20 to 40%, C 40 to 60%, option D is greater than 60%. So the answer is option B 20 to 40%. So the next question is saltwater intrusion is a problem in option A coastal areas, B desert, C forest, D marsh or wetland. So if you remember, we have discussed that in case of coastal areas, since they are very close to the ocean and the ocean water is salty, if the groundwater table goes below, there is possibility that the salty nature of the ocean water can enter this fresh groundwater as well, which will make them salty. And this is procedure. This is called as saltwater intrusion. So it is a problem in coastal areas. So the next topic is geomorphology of watershed. So it refers to study of characteristics, configuration, and evolution of landforms and properties. Okay, mostly it comprises characteristics of land surface as well as characteristics of channels within the watershed. Okay, so then what we're trying to do here is we are trying to quantify the geomorphological properties that will significantly affect the runoff and other hydrological processes. Okay, so it governs flow of water from overland to channel and also from channel of one order to another. Okay, so that's why it is very important to understand the geomorphology of the watershed. And this geomorphological nature can be easily determined using contour map and drainage map of basin. Consequently, several geomorphology based hydrological models are developed and are in use currently. Okay. So the morphological characteristics of watershed are classified mainly into three types. First one is linear aspect, second one is areal aspect, and third one is relief aspect. Okay. So first we will look into the linear aspect or 1D. Okay. It is concerned with mainly the streams and the stream networks. Okay. So in this we have multiple characteristics. First is basin length, L. So there are different various definitions for basin length. My first definition is the longest distance between 2 points in a watershed. Suppose this is the basin. Okay. So the longest between 2 points will be this, right? But in this case, this is the outlet. So we are not fixing which are the 2 points. We are just taking the 2 points which are farthest from each other and measuring that distance. That distance will be called as basin length. The second definition, the distance between the outlet and any point on perimeter which is farthest is called as basin length. So here, this is our outlet. We are fixing this. And the second point we are considering which is farthest from the outlet. And this length is called as basin length. Okay. And the third definition is length of mainstream from source to outlet point is called as basin length. The next one is basin width, L. So the perpendicular drawn to this basin, okay, this length is called as basin width. Then basin perimeter. Is the, as we already know the definition of perimeter, it is the outer boundary of any shape, right? So for the basin perimeter will be the outer boundary of the watershed that encloses the area. So this boundary, which is enclosing the watershed, the length of this boundary is called as perimeter. Okay, it will indicate the size and shape of the basin. The next one is stream order. Okay, there is a hierarchy of stream ordering, and the order of basin is order of this highest order stream channel. Okay, so here there are two methods based on which we can assign order to to the streams. The first one is Horton, Strahler stream order. In this, the main assumption is that how we start the ordering of the stream is that the first order does not have any tributaries. So suppose if you see in this figure, whichever streams that are assigned the order 1, okay, you can see there are no tributaries for this stream. So for those kind of streams, we assign the order as 1. And the junction of first two stream orders will result as a second order stream. So these two first stream orders are joining here, and the resultant stream will be of second order. Okay. So similarly, if two second order streams join, it will result in a third order stream. Okay, like this one, it will keep continuing. So, is there any questions related to this Horton Strahler stream order? There is none. Then I will discuss about the next one, that is stream order. So here also what we will be doing is that first order streams, we will be assigning 1 because there are no tributaries. For those streams, we will assign order 1. And based on it will take In this case, it takes into account stream magnitude and is preferred in hydrodynamic. Okay. So suppose if we are saying two first order streams are joining, it will result in second order stream. Suppose a second and first order stream is joining, it will be like 2 plus 1. Okay. Then it will result in third order stream. So if you see here in this case, a third and second order stream is joining. 2 plus 3 is 5. So it is giving us a fifth order stream. Okay. Is this clear? The difference how the Horton standard stream order is assigned and how stream order is assigned for the streams? So once we know the stream order, suppose here if you see in this case, the highest stream order is 4, right? So then we will assign for this basin, it is a fourth order stream. Okay, in this case, in this example, it is a sixth order basin. Okay, because the highest stream order is 6. And the next characteristic is stream number. So in this, what we are doing is we are counting number of segments of a particular order is counted and expressed as a number of particular order. So that means, suppose if you see here, in this case, you see there are multiple number of first order streams. So we will just count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the stream number for first order, okay, N1, first order streams is 11 here because there are 11 first order streams. Okay. Here the denotation is given as NU. U is the order of the stream. Okay. The next one is bifurcation number or bifurcation ratio RB is equal to NU by NU plus 1. That is the ratio of stream number of your order stream by divided by ratio of U plus 1th order, stream number of U plus 1th order. Okay. So generally RB varies from 3 to 5. Okay. So it will be useful in expressing the branching pattern of the stream network and also it measures the drainage density. Okay. Next we have stream length. So what we are doing here is we know here that in this case there are 11 first order streams, right? What we will do is we will measure the length of each stream of first order. So 11 first order streams length we will measure. So 11 measurements we have. So once we add them up, we will have the length of the first order stream. Okay. And if we can calculate mean also. That is what we are calling it as stream length. The next one is stream length ratio RL. RL is the ratio of length of uth order stream to u minus 1 order stream. Okay. So the next one is length of overland flow. It is referred to as maximum length of surface flow before reaching the stream. Okay. So these are the different types of linear aspects that we will be using. And now let's look into the various types of areal aspects. So the first one is watershed area. So it is defined as the area contained within the vertical projection of the basin divided on a horizontal line. Okay, so in this we have two types: stream area, which is the area draining to a predetermined point in stream or outlet. Suppose if you have a stream like this, and we are talking about this point, whatever the area that is contributing to this to the flow at this point is called as stream area. This area is stream area. Okay. Next is interbasin area. So this is called as area contributing flow directly to stream of order higher than 1. So if you see here in this example, so these are all first order streams, right? So this area is is contributing flow to the only first order. But in this one is here for this point, the flow is coming from both first order and second order, right? So this is called as interbasin area. So what we are doing is generally, because here for this point, this entire area is contributing. For this point, this entire area will contribute, right? Which this entire area. But this is first order area, and this is the area that is contributing for second order. So this difference between two different order is called as interbasin area. The next one is stream area ratio. It is given by formula RA is equal to AW by AW minus 1. So generally it will range from 3 to 6. Okay. So then we have watershed shape. Generally it is mostly pear-shaped watersheds are more common. There are different dimensionless factors that are associated with the watershed shape. So first one we will be talking about is form factor. RF is defined as AW by LW square. Okay, generally this value will be less than 1. And in case of fan-shaped watershed, RF is equal to 0.786. For a fan-shaped watershed, it is generally less than 0.786. Okay. And the smaller RF means greater elongation. So next factor is shape factor. It is defined by this ratio LW square by AW. The next one is elongation ratio, 2 by LW square root of A by pi. This by after solving we can just write it as 1.128 A power 0.5 by LW. Okay, so generally it varies from 0, which means elongated, to 1, circular. Then we have circularity ratio. It is given by formula 12.57 A by P square. So also it varies from 0.2 to 0.8. But we have one more coefficient, compactness coefficient, which is inverse of circularity ratio. Okay. So the next characteristic is drainage density. It is given as length by area by Horton in 1982. Okay, so high drainage density will indicate like large portion of precipitation is converted into runoff. The next one is constant of channel maintenance. So it is inverse of drainage density. So if there is a low CCM, that means high flow potential. Okay, since it's the inverse of drainage density. The next one is stream frequency. Here, it represents the number of stream channels per unit area. Okay, so these are all the areal aspects. Now let's look into relief aspects of geomorphological characteristics. Basically. Okay, the first one is watershed slope. That is SW equal to HF by LF. So HF indicates the elevation difference between 2 points and LF is the distance between those 2 points. This will affect the velocity, momentum of runoff and erosion potential of watershed. So the slope also affects the groundwater recharge. Since if it is more steep, the water will run off. It won't be there. We won't have enough time for it to infiltrate. So it will affect the groundwater recharge. Okay. Next one is watershed relief. So we have different terms in this as well. Absolute relief. First one is R. It is the maximum altitude of a basin. Yeah. The next one is relative relief. H. It is the elevation difference between highest and lowest point in a basin. Okay. Then we have relief ratio RH, which is the ratio of watershed relief to longest dimension of watershed parallel to main flow path. Okay, so if there is an increase in RH relief ratio, it implies the slope is steep. Next one is dissection index, which has a formula di equal to h by r. So it will give us an idea of vertical erosion. Next one is ruggedness index, Ra, that is Dt into H. It indicates the young and old stage of the watershed. Okay. And so the morpho for using all this, what we are trying to do is we are trying to analyze the morphometric nature of the watershed. Okay. It is a qualitative measurement of morphological characteristics. All this analysis will be helpful in water supply management, okay, and flood prediction, environmental planning, etc. So how we are going to do is this, like how do we know the area of the basin? We can't, because if it is more than 2,500 kilometers square, how we will measure it? So for that, what we are doing currently is we have remote sensing. So what is remote sensing? Okay. So remote sensing is acquisition of information about the earth surface without coming directly into contact with the surface. Okay. So So remote sensing acquisition of information about the Earth's surface without direct physical contact. So without any physical contact, how we are trying to get the information? What we will do is we will be using satellites or aerial image, that is using drones or aeroplanes, etc., helicopters. What we'll try to do is we'll get some information, and that from that we will process it. So how we will get information generally from these kind of things like satellites, aerial images? It will be a picture, right? How we will try to analyze. So what we will be using is we have a GIS, Geographic Information System, which is a powerful tool, allows us for spatial analysis and data visualization. So suppose we are taking a picture of an area, the area will have some geographical location. So when we are trying to analyze it, we need this kind of geographical data as well. So in that case, we use GIS, which will help us in analyzing the data with its geographical coordinates. Okay, and also it will help. We can visualize the data also in these softwares. Okay, it allows us integration of various geospatial data sets, including satellite imagery, topographic maps, and hydrological information. So mostly, what are the GIS softwares that are available is ArcGIS, but it's not open source. It's a paid software, and QGIS. QGIS is a open source software, and you can see in the professor's lecture also. He was giving a tutorial of showing how watershed delineation we can do in QGIS, and how to calculate stream order, stream number, stream length, etc. Whatever the linear, aerial aspects, relief aspects that we are talking about, he was giving a practical demonstration by using QGIS, how we can get these characteristics for a watershed. Okay, please go through that lecture. And in that, was discussing about what is watershed, how do we do watershed delineation. So, what exactly is watershed delineation is? We are trying to identify the boundary of a watershed. So, suppose in real life, we will have a stream networks like this. So, suppose we are considering this as outlet. So we want to know what area is contributing to this to the flow at this point. So when we want to know what area is contributing means like we want to have a boundary. Okay, a boundary for the area which is contributing flow at this point. So this boundary is identified using watershed delineation process. Okay. So typically, based on topographic maps, we will generally draw this boundary. Okay. Nowadays, we are doing it using QGIS or ArcGIS. And for that, the main input that we will be using is DEM. Okay. Digital Elevation Model. Okay. You can see that it is downloaded from USGS source. So like that, we can obtain the DEM of any area and we can obtain the boundary of a watershed using watershed delineation process. So once we get this boundary, we know the what are the streams that are in the watershed. We can calculate stream order, stream length, etc. All this morphological aspects can be calculated. Okay. So now let's look into questions related to this topic. The first one is study of characteristics, configuration, and evolution of landforms and properties is called as option A, hydrology, option B, geology, option C, geomorphology, option D, none. So we know hydrology is the study of water within a catchment, and option geology is about rocks and other. So it is option C, geomorphology. So the next question is geomorphological characters can be easily determined using option A, rainfall data, B, curve number map, C, gauges, option D, contour map. So we have discussed that using contour maps, we can easily determine the geomorphological characteristics of a catchment. So next question is, which of the following are linear aspects of morphological characteristics of watershed? Option E, basin length. Option B, stream order. Option C, bifurcation ratio. Option D, length of the overland flow. So if you remember, we have discussed all these uh, characteristics in linear aspects only. So all the options are the answers. So according to Horton-Strahler stream order, the junction of two second order streams result in option A, second order stream, B, third order stream, C, fourth order stream, D, none. If you remember, so two first order streams will join to give us a second order stream. Okay. And two second order stream will give us a third order stream in Horton-Strahler stream order. So it's option C. So the next question is the stream number of first order stream is. So here what we have to do is we have to count number of first order streams. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the stream number of first order stream is 10. So the next question is the bifurcation ratio RB is. So if you remember the equations that I have discussed earlier, the bifurcation ratio is defined as RB equal to NU by NU plus 1. So the answer is option A. So next one is the form factor is defined as. So if you remember the dimensionless factors that are associated with watershed shape, we have first one as form factor, which is defined as RF is equal to AW by LW square. So that's why the option is C. So the next question is high drainage density indicates. Option A, low portion of precipitation is converted to runoff. Option B, large portion of precipitation is converted to runoff. Option C, both A and B. Option D, none. So if you remember, if the drainage density is high, large portion of precipitation is converted into runoffs. So option is B. The next question is the watershed slope affects option A runoff velocity, option B runoff momentum, option C erosion potential of watershed, option D all of the above. So the answer is that if the slope is higher, velocity will be high than compared to a mild slope region. So even the momentum will be changing, and the erosion will be higher in case of steep slope than in case of mild slope. So all these factors are affected based on the watershed slope. So the answer is option all of the above. So the next question is the dissection index is. If you remember, the formula that I have written is equal to H by R, that is relative relief by absolute relief. Okay, so the answer is option A. Now let's look into the watershed management. So the next topic is watershed management. So here we will be talking about what is watershed management and why is it important, all this. Watershed management. So remember, maybe you might have an idea of what is watershed management. So basically, what we are trying to do is here it will guide and organize the land and resources so that we can use them sustainably. So how we are defining is that it is defined in terms of effective soil and water conservation for sustainable agriculture with little pollution. Okay, so it is defined in terms of effective soil and water conservation for sustainable agriculture with little pollution. In conclusion, it will provide us a foundation for developing and conserving natural resources. But the main focus will be on how human activities affects water and other resources. Okay. So why is it necessary? Uh, why watershed management is necessary for any catchment? So it is necessary because generally any watershed consists of multiple parts. Okay, so whatever rainfall or any input that is coming, it will be interacted with multiple parts within the watershed, and finally we are getting an output. Suppose runoff. Okay, so since there are multiple parts that are involved, we should operate them in an efficient manner so that we can get benefits out of it. Okay, so that's what we are first necessary is watershed has different parts which are connected physically and operationally. So we should run it in an optimized manner to get our benefits. And without proper care, we might lose important resources and we can pollute the watershed also. Without proper care, which will affect people and animals that stay within the watershed. Okay. So mainly this is important for in case of floods, pollution, water quality, etc. These are all the reasons why it is necessary for a watershed management. So how do you explain the concept of watershed management? So we generally explain it using an acronym called POWER, POWER. So, so here P represents the production of food, fuel, fruit, fiber, fish, milk combination, etc. within the watershed, pollution control, prevention of floods. Okay. And O represents the over exploitation of minerals should be minimized, operational predictability. W is like water storage of convenient location. Wild animals and indigenous plants should be conserved. Okay. So E represents erosion control, economic stability, ecosystem safety, employment generation, uh, etc. within the watershed. Okay, all these are interlinked. And R represent rainwater harvesting, recharge of groundwater, reduction of drought hazard, recreation, reduction of siltation in multipurpose reservoir. Uh, so that's how this acronym is used to represent the concept of watershed management. So all these things that I have said, we will be doing in case of watershed management. So how watershed management in India is happening. So we have in case of pre-independence era, we are using traditional methods like we are constructing tanks, etc. to store water. Okay. Sarah, we are using traditional methods. Post-independence initiatives, that is in between 1950s to 1970s, we have like river valley projects like Damodar Valley Corporation, etc., that came up during this period. The next one is Rural Development Program, in which drought-prone areas are concentrated. Okay, this came up in 1970s. The next one is Watershed Development Project, in which rain-fed areas are concentrated. Okay, in 1980s. So then what they did is they integrated all these sub branches into one particular branch, integrated watershed management program. So all these programs now come under this in 2009, and currently also we have Mahatma Gandhi National Rural Employment Guarantee Act for maintenance of the watershed. Okay. So also, so these are the how these are this is how the watershed management is taking place in India. So what are the main principles associated with the watershed management? Okay. So main principle is that we should encourage the participation of community in the watershed and multidisciplinary collaboration. So all this, like we should, the engineers should come up, and scientists, the local people, everyone should come up together, contribute for the watershed management, and the gender inclusive programs, integration of local wisdom, realistic goal setting. So, like this, we have multiple principles of watershed management. The other ones are like dual focus on conservation and production, flexibility in management, sharing for sustainability. Next one is alignment with food security and rural development. Next one is dynamic adaptive approach. Next one is like a strategic partnership and communication. All these are the principles of watershed management. So generally, how this watershed management planning will work is, so first we should get the required data. Then, based on the data, we'll set main objectives based on data. And based on objectives, we know what other methods and strategies that we can apply for the watershed. So these method and strategies might not, suppose it is if it is working for a particular basin, it might not work for another basin. So we have to come with multiple methods and strategies, and we should know which is more suitable for this particular watershed. And then we do priority settings. So in the watershed, if it is a large watershed, we cannot work on the large watershed at once, right? So what we will try to do is we will first identify the priorities area. So suppose if the main problem is floods that are occurring in the watershed, so what we will do is we will try to identify which are the areas which are mainly facing floods more frequently, okay, and getting damaged. So those areas will first apply the watershed management methods and strategies. Then we will reduce the flood impact in these areas. Slowly, we'll move on to other areas of the watershed. Also, like this is one of the example. So the next one is steps involved in watershed management. So first one is we will do the survey to get the data, rapid reconnaissance survey. Once we get the data, we'll try to recognize the problems that are problems or issues within the watershed, that is recognition phase. And then once we know the problems, we'll try to restore it using some methods or strategies. Then we will have a protection phase where we will try to protect the wildlife or any other natural sources of the watershed. Okay. The next one is improvement phase. As the name itself suggests, we will try to improve the watershed that is under consideration. So next is we will be talking about how we are trying to do watershed prioritization. So in this we have two methods. The first one is sediment yield index S by I. Okay. So it is defined as SYI is equal to erosivity into erodibility. Erosivity is a function of rainfall characteristics. Okay. Erodibility is a function of soil characteristics. So SYI, the formula for it is AI into WI into 100 for I equal to 1 to N. So WI is the erosivity, DI is the erodibility. Sorry. WI also is defined as erosion intensity weightage unit, and DI is delivery ratio, and this is the area of AI represent the area of this particular unit, and we are dividing with the total area of the watershed. Okay. So the next method is runoff potential index, RPI, which is used in flood-prone catchments. It quantifies the total quantum of runoff generated per unit area. So RPI is equal to sigma of AI into WI by AW into 100. WI is the runoff potential weightage assigned to ith unit. Okay. And I varies from 1 to N, where sigma AI is the area of the particular unit I. So then we will talk about components of watershed management. So mainly we have three types. First one is land management. Second one is water management. Third one is biomass management. In case of land management, we have sub-classifications. We will manage land using vegetative measures, structural measures like constructing dams or check dams, small structures within the basin, protective measures. We will try to prevent the erosion of the soil using some. So we will put small rocks on it so that the protection can happen, and production. So yield of the catchment also depends on the land, right? So we'll try to improve the land and see which type of crop is better for the particular land, etc. Like that, we will improve the production also. So we also have few other terms like participatory watershed management. As I have told, it's like including all the members of the community, that is engaging them in the participation so that we can manage the watershed. Then next is integrated watershed management. So all the, as you have seen earlier, we have integrated all the programs within India itself to one main program, integrated watershed management. Like that, all of them should come together, and integratedly we have to manage the watershed in any area. Okay. And the technologies and tools involved in the watershed management are, we will use remote sensing data, GIS, and also big data like rainfall, temperature, everything. We can get from various sources, and using this, we'll do the watershed management. So let's look into few questions related to this topic. So the first question is, the sediment yield index is. So if you remember, I've written sediment yield index as AI into WI into DI by AW into 100. So the answer is option C. So the runoff potential RPI is defined as sigma of AI into WI by AW into 100. So the answer is option A. So the next question is, which of the following measures come under land management? Option A, vegetative measure. Option B, structural measure. Option C, production measure. Option D, all of the above. So if you remember, in land management, all these measures will be applicable. So the answer is option D, all of the above. Okay. So that's it for today's class. In today's class, we have talked about different drainage basin characteristics, different types of watersheds. Okay. Also, geomorphological characteristics of watershed, how we can estimate them using remote sensing and QGIS. Okay. And then we have talked about watershed management and how watershed management is applied in India, etc. So all this we have talked about. So if you have any questions related to this topic, you may ask questions. So if there are no questions, we can end the session. I'll wait for 5 more minutes. If there are no questions, we can end this session. Okay.